for what's the 80% rank. But when I applied 17 as this line, all right, I ended up getting 60% of potential rainfall is here and 40% is above. So what does that tell me the actual water quality depth needs to be? Higher or lower? A fair amount higher, in fact. And so I'm going to guess, but y'all have to try to check me on this. Let's try 30. All right. Or you can just write the program that spits this out. But what I did with Professor Vienarossi is I literally picked 17, summed all the precipitation values above 17, put that into a pot. Then I summed all of the, then I subtracted 17 from whatever value exceeded 17 over here. And that difference, I summed that and put that in a pot. And then I counted all of the storms that exceeded 17 and multiplied those by 17, right? Because the storm control measure, even if it's a massive storm, is still treating at least 17 millimeters of it, subjecting 17 millimeters of it to treatment. And so when I did that, that's how I got these values. So that's the right way to do it, but it's kind of inefficient without me having a good equation set for the spreadsheet. So if y'all could go ahead and try to figure that out, you're very smart. There's a lot of very smart people I'm looking at in this room. I know you're going to be able to do it. And I'm perfectly happy for you to talk to each other to help figure it out. You think Vienarossi and I are talking? Yes, we are. All right. So go ahead, work if you'd like to with somebody, but please try to figure out what value here, and it's higher than 17, captures 80% and leaves 20% to bypass. Everyone good? Everyone, you got an answer? What did you get? You don't have an answer yet? Okay. Okay. So there is a value, there is a rainfall depth, all right? It's not 17, but right now I have it listed as 17, where if you looked at every storm that fell up to that value, plus all the other storms up to at 17 millimeters, that all of this equates to 80% of the rain that falls, all right? And then everything above this line, all right, is bypass. And then the total amount of bypass would be 20% if you added all of this area. If you could integrate, all right, essentially this is an integration problem, all right? But if you integrated all of this as it shoots up, right up through there, that would be 20% of the total rain that falls. So that's what we're trying to get at. And I know that 17 is not it. 17 basically has 40% bypass and 60% treatment. Okay? And so with the data that you have, what I'd like for you to do is figure out what value gets you 80% subject to treatment and 20% bypass. And from what we said, 17 is too low of a number. It's going to be actually a fair amount higher. And I had suggested to Vienarossi that maybe the number is about 30 millimeters, which, by the way, is in line with a lot of southern states. 1.2 inches is right at 30 millimeters. And 1.2 inches is what many states south of North Carolina use. North Carolina actually uses 25 millimeters. All right. So, but 30 millimeters would actually be in line with the typical southern state that gets 1,200, 1,300 millimeters of rain a year, which is in line with what Rookie gets. All right. So are you good if I set you free on that data to try to figure out the 80-20 split? Yes, no? Yes. Thank you. All right. Now, good luck. And if you want me to come and look what you've done, I'm happy to do that. One of you is going to find a very efficient way to do it. I don't know what happened to my name tag, but something happened to it.
Somebody
You got 20. Okay. What did you guys get? 37.16? 57? 67? Well, that's a big storm. Anybody else? I'm going to tell you what Professor Vinarasi and I got. 34 to 35. Which, by the way, does make sense to me as a number. Vinarasi, you want to talk about how you, what you did to calculate the numbers?
Yes, yes.
Okay, okay, great. Okay. The things to make sure your calculation do is one, at whatever your threshold value is, let's say it's 30, okay? That you sum up all the rainfalls that were less than 30. Boom. So that's one big sum. You put that into a pot. Then the next thing you do, and just maybe what you did, is you look at all of the rains that exceeded 30, okay? And then you basically look at that number. Let's say there's 1,000 storms that exceeded 30. You multiply 30 by 1,000 events, because there's 1,000 storms that we caught up to 30 millimeters. Okay, so you sum those together, put that in a pot, and then you add those two together. All right, so that's the total amount treated. Then with 30, you'd look at all the storms that exceeded 30. You subtract 30 from every single one of those storms, and they're going to get a difference. And then you add that difference up, and then that's the amount of bypass. Okay? Then you add your bypass amount to your treated amount, and that's the total rain, which you could have just done to begin with, but that's your total rain, and then you divide your total rain by everything that you captured. And then if that number is at 80%, then you've determined your water quality volume. So that's how we calculated it. All right. 20 is probably low based upon 17.
Anybody is having doubt? If you have a doubt, please say.
Okay, yeah, that sounds great. Vinarasi is going to give it a shot since I have failed you. Well, yeah.
Suppose 80%, you want to know what is the 80% amount.
How about I get rid of my marking?
You have randomly only fixed the amount, okay? So we have just taken 35 mm. Okay, 35, 30. Okay, so what is the formula we have used is? The total rainfall, okay, actually we have taken below this. Suppose this is the 30th percentile.
Or actually 30, okay.
Sorry, 30 mm.
Yeah.
Suppose if you take 30 mm. Okay, suppose if you take 30 mm, 30 mm is the threshold. It is not a threshold here. It is a threshold somewhere here, right? 30 mm will be there. So 30 mm, suppose this events are 240, means you have to subtract that 30 in that, right? So you subtract the 30 in that, then you get the rainfall. So whatever positive values you are getting, right, that is the excess water which is passing, which will not be accommodated by the LID, right? So that you total it, okay? And then remaining amount, okay, which are the negative values are coming, that not the negative values, the actual values of that, and then the subtracted values for the below. For example, suppose 50, 17, this is your actual rainfall, okay? So here onwards you will get a positive, right? Here it will be 5 mm, sorry 10 mm, 5 mm, here it will be negative 10, right? So now here the remaining is 30, Remaining is, sorry. Here also 30-30 only. The subtraction is 30-30, right? So you add this total, okay, and then 30 into number of points. If you are multiplying, you will get, right? That is the amount. That is the total amount which will be accommodated by the LID, right? The total amount which will be accommodated by the LID, and then total amount which will surpass, right? So take the fraction, you will get to know how much is LID will accommodate, right?
That is our,
30 mm is a threshold we have taken. So like that I took 35 mm threshold, then I found 80 percentages will be accommodated by the LIDs. Like if you are, yes. Hit and trial में मैंने किया था, but you can do it. See, just we want to make sure at least we are designing our, see, we are putting some efforts to design this LIDs and all. At least it should accommodate 80 percentage of the runoff,
of the runoff.
rainfall.
It's basically rainfall.
Rainfall.
Yeah.
Means it is not about the runoff के लिए, it is mainly for estimating the pollutants.
Correct.
So this much amount, at least 30 to 35 mm is needed. I think that is the amount which carry the pollutants, right?
What we're saying is that the majority of pollutants, a disproportionate amount of pollutants are carried by smaller storms, okay? The first flush, think about smaller storms transport a disproportionate amount of pollutant from a watershed. And so over the course of a decade, the smaller storms which you're capturing are contributing more pollutant load per millimeter of rain than your big storms are contributing per millimeter of rain. All right? And so you want to pick a threshold that captures all of the small storms plus a fraction of the big storms.
You understand? First he told the first flash will carry the high amount of pollutants. So we want to capture all the smaller storms. Even in the bigger storms also, we are just taking that starting amount of precipitation. Okay. So for that, generally they model with 17 mm.
Mm-hmm.
That's
Initially
what
with 17.
17,
right?
but when we use that 17, we found that is just capturing 60% only. That's why I tried with the hidden trial to get at least 80.
17 allowed 40% of rainfall to bypass. And we deemed 40% of rainfall to be too much rainfall to bypass, with our target of bypass being 20%. All right? So curiously, if you doubled, this should not have been this not necessarily this way, by doubling 17 and making it 34 or 35, you're actually capturing 80% of potential runoff and allowing 20% of the potential runoff to bypass. The reason we spend all afternoon talking about this
You have a doubt.
is it's very important, the number, because it dictates the size of a lot of practices. Does everyone understand the idea behind the water quality volume?
I think you left me aside.
No? Okay.
So we are not using
Yes.
that value of 65.16.
The 35 mm that
Yes.
we have considered.
Yes.
The rainfall that said is below 35 mm, we are considering that to the pollutants.
Yeah, and fully captured
We are
See
collecting that
here only what I
for
have done.
pollutants.
for pollutant
We are
removal.
not using
That's correct.
67.
That is correct.
Go to 67.
80% of the total rainfall.
You- Over the course
You
of
fill with
a
the percentage.
decade,
That is
if
the
you
percentage.
continued to capture 35 millimeters
80
runoff
percent.
associated with 35 millimeters of rain in a highly
17
impervious catchment,
But that is if I use the
capture
maximum
about
80%.
90% of the pollutant
That
load by capturing
taking
roughly
only
80% of the
60%.
rainfall. okay?
Runoff means the amount of precipitation which can bypass the
So I will
yellow
start,
or 40%.
knowing this number,
That
I
is
will
what
start
right?
and review where, when I walked in and see how all this plays
Accommodated by the
in,
glider.
all right?
It should pass through the glider.
So
Okay, only 20% can bypass.
I'm gonna
for
sink
that,
this
We have done with the
down
hitting
here.
side.
Oh, no, that's not
So,
working.
Maybe 35%, 35 mm might be 90th percentile.
Okay, can we make that white,
Data.
please? Thank you.
See, initially he told it.
Okay, that would do it.
Percentage
And can I
of
get
this.
the whole, yeah, you know what you're doing.
80th percentile was coming out to be 17. But that 17 mm, 80th
Thank you so much.
percentile of the rainfall is 17 mm, which
Is
is
it possible to get a white screen?
accommodating.
Can I swipe,
This one
so I
is
swipe?
accommodating
Oh, that's right, 'cause like, yeah, from the
60%
lectern.
of
Yeah, there is a white screen on that lectern somewhere.
40% is bypassing.
Okay.
So we want to reduce this
I
number
wonder
to
if at
80.
any
Increase this
point
number to 80,
I will
this to 20.
figure out how to use this.
That is happening with 35 mm. I came in the back burner. You understood?
From this value,
Hmm.
17 mm.
The whiteboard,
17
yeah.
mm, we rise to 13, then it is accommodating 80 mm, 80% runoff. Understood?
Then
Whiteboard,
understood?
that's it. Thank you.
You all understood what he has told?
Okay, there's our whiteboard.
You didn't understand. No. Actually, what he was trying to say is
Okay,
what he told.
thank you.
Like that is not
Okay,
80%, right?
so when we started today,
Actually, 80%
we talked that there's two
precipitation is 17
storm sizes
okay?
that you design a
80%
stormwater control measure for, a wetland, a bioretention cell.
of
The first
rainfall
one
is
is what? The one we didn't spend all our time calculating.
17 mm.
The big
From
storm,
this we
all
have
right?
calculated
And
how
so
much
so we have an
water
SCM, stormwater control measure.
So
That is
80% of the yes. So it accommodate only 60% approximately, right?
We have runoff, okay,
what we
coming
have
in. I'm
is
gonna make it into a box,
30, 35.
into an SCM, or a stormwater control measure, also known as part of green stormwater infrastructure, okay? In fact, if you want, I'll
35 is
put
coming 80.8.
plants in it. These look like plants to you?
80.8, it's coming.
Let's engineer for plants, okay?
80.8 is coming.
So we have
30.
runoff. Runoff is coming into your stormwater control measure. And you design,
Okay, he started now.
all right, your SCM for two storm sizes, okay?
35.
One
but
is for flooding.
35 पे 81 आ रहा है. 35 ले लिया.
And in rookie,
8 is coming.
all right, that has been determined to be the 2-year, for most storms, 24-hour
See, what he told. See, we have
rainfall depth,
situation like this.
which is 109
So in this
millimeters,
case,
okay?
it is
So that's the
below what
storm
you have provided.
that when it comes into the stormwater control measure,
Runoff.
we're trying to limit the flow rate out,
So initially,
all right? We're not trying to capture the entire storm and hold it long enough so that remove pollutants. We're just trying to limit the flow rate out, all right? So this is that 109 millimeters. This is flow. This is all about determining a flow rate out, or a Q discharge. All right. The second storm size that we're gonna that we need to capture or need to design for is the water quality event, which is associated with first flush. I know we did not all get the same values, though I do trust the values that Vinarasi and I got, all right? So there were two different ways of trying to calculate it. One was to literally rank every storm, look at the 80 percentile storm, all right, which was 17 millimeters, all right? Or look at a little larger storm, but all of it is based on, so this is the water quality storm, okay? But the water quality event, okay, is based on, is a function, okay, of what is known as the first flush. Okay. So what is the first flush? The first flush is this idea that when it starts to rain, more pollutants are being delivered to the outlet at the beginning of the storm than at the end of the storm, okay? And if that stands to reason, hopefully it makes sense to everybody, that over the course of a decade or 3 decades of data, small storms are also contributing proportionally larger pollutant loads than big storms, okay? So if you looked at the pollutant load associated with a 10 millimeter event and compared that to the pollutant load associated with a 100 millimeter event, the 10-meter event will actually deliver a larger proportional pollutant load, like pollutant per millimeter of rain. So that's what the first flush says. Is everyone on board with that concept? Okay, great. And so knowing that the water quality storm is associated with the first flush, and knowing that the first flush favors more pollutant loads for smaller events, this is necessarily, and it's cumulative over the course of a year, this is necessarily going to be a smaller storm size. All right, so 2A is that if you rank all the storms, the 80 percentile ranked storm event is 17 millimeters, all right? But that 17 millimeters is not accounting for exactly how much is bypassing in big storms, okay? So basically we're saying if you have a 200 millimeter event and you're capturing 17, then the 17 doesn't even care how big the storms are that are behind it, all right? But we're saying that the value actually should account to some extent for the storms that exceed that whatever threshold number you pick, all right? So 17 did not consider how large the storms are behind it, all right? So this excludes, the calculation more or less excludes, I'm going to call them big storms, all right? It's not quite right, but it's close to being right, all right? So your other option for calculating a water quality event is to make sure you treat some fraction of water associated with all of the storms, all the big ones, and then 100% of all the small ones. And the way that's calculated is through integration, where you allow some fraction to bypass, but you're also capturing even to the largest storm, you're capturing some depth of rain that you want to be treated. All right. Now, by going through the calculation where you sum all the rain up that you capture, you sum all 30 millimeters or whatever the number is of the threshold for all the storms that bypass, and then you sum all the rainfall depths that bypass. If you sum those into 3 pots, so you've got a bypass pot, treatment pot A, treatment pot B, combine the treatment pots, treatment numbers, add the treatment numbers to the bypass numbers, and then divide the treatment number by the total rain. When you do those things, okay, there's part 1, all the rains up to the size of the storm you want. Part two, 30%, or not 30, 30 millimeters to 25 millimeters of whatever storm, all the storms that exceed it. And then part three is the bypass, the value of all the bypass above that threshold. You add all those up, combine them, the amount that's treated should be 80% of treatment. All right, so I'm going to call this, if we do, instead of 80% ranked, we're doing 80% treated. All right, which includes the big storms. We get something like 34 or 35 millimeter. And that includes all, let me get rid of that, all storms. Okay? So we're treating for flow only, 109 millimeters, but the water quality volume, this either 17 millimeters or 34, 35 millimeters, this is the volume that you will, this is an important volume. This is the volume that you will hold and treat for water quality. Okay? So it's this volume, the rainfall associated, the volume associated with this rainfall that we are calculating to know how big a footprint our stormwater control measure, our LID system, our green stormwater infrastructure, whatever word you want to use. It's this volume here, either the A or the B, that's going to determine how big your practice is. All right? This one is about flow rate. This is about capturing a volume, holding it, and slowly releasing it. The reason I put so much effort into trying to figure out what these values are, all right, especially this one, is because it shows up in every single SEM sizing calculation you have that is based on capture, volume captured. That's based on the capture volume. So for ponds, for wetlands, for bioretention cells, for permeable pavement, all of those we care about how much water we're trying to hold and detain, all right? For swales, it's a little bit different. We actually worry about flow rates on swales. But for ponds, wetlands, bioretention cells, green roofs, when we design green roofs, we worry about that as well. We all, in those cases, we're worried about capturing a volume of water with it. And so that's why this number or that number is important. If you went with 17 millimeters, that's not a very careful number. That's not a cautious number. But it may be the financially acceptable number, all right? Because your practice is literally going to be twice as big with this number compared to that, right? If you're asking a stormwater control measure to capture 35 millimeters, well, that's twice as much as 17 millimeters. And if you have a fixed depth, which you do, which we'll talk about in the coming days, that literally makes your practice twice as big, all right? And so for some people, I'm like, you know what? I can't afford that. I don't want to afford that, all right? But if you want to try to be true and get 90% of the pollutant load, then the better number to use is 34 or 35 millimeters, because that's going to subject roughly 90% of the pollutant load to treatment. Okay, is everybody on board? Yes. You probably figured out I'm a vocal person. And so if you say no, it is totally good. And I'm happy to try to explain it a different way. But if you get it, that's great. And so thank you for letting me know. And so what we're going to do, the last thing we're going to do before we break for the day is just show you how you would calculate a runoff volume associated with these numbers. Okay? And there's a couple of different options. Do you use the SCS curve number methodology here? Yes? No? Okay. There's a couple of different ways. One is you can calculate a runoff volume per a depth, but it's very simplistic. It's all based on impervious surface. The second one is based on curve number. And I tell you what I'm going to do. I will go through that when we talk about wetlands on Wednesday. It'll be a very germane calculation when we talk about wetlands on Wednesday. So our take home point is 109 for flooding. And I'm going to go ahead and put 35 down here, but I'm open to use the lower number. 39 for flooding. 35 for water quality. I will talk about this number and use that number on Wednesday, and we'll actually touch base and use it tomorrow as well. If you guys have any questions, it's 5 o'clock. I don't want to keep you any longer unless you guys have questions, and I'm happy to answer any questions you got. Okay? We are going to use the 35 millimeters to decide stormwater wetlands on Wednesday. And I'll just go through the calculation then. Okay? All right. I am not going to walk out of here when class is over. So if any of you have questions you want to ask before you go out, that's fine. But I do wish everybody a good day. And I appreciate everyone coming. And I hope you enjoy whatever food you decide to eat tonight. All right? Okay. We're good. Anything you want to add, Vinarasi? Yeah. I'm happy to answer them for the class. I'm happy to answer them individually.